All right, so we're going to jump into chapter 12. 12.1 is a bit of a long section only because we have to introduce a bunch of new terminology and concepts. So this will probably be broken up into a couple of videos. But yeah, let's just go ahead and start. So we'll start with a couple of definitions. The first thing we have to discuss is what we mean by a population. So I say in statistics, a population is going to be all the possible things. So if I wanted to get a survey about a certain thing about students on campus, then I might ask all the students. But if I only wanted to ask about commuter students, then I wouldn't need to ask about, or I wouldn't need to survey every student on campus. I would only survey those students who are commuters. So the population is the group, the entire group we're interested in. And a random sample is going to be when we take a subgroup of that population. So it wouldn't be logical to try to interview or survey every single student at LSU. You have some that are online, you have some who are on campus, some who only come at night, some who don't come on Fridays, etc. So there's lots of things. So what we would do is we would come up with a random sample. So the next thing I want to look at is, let's just take a situation. Okay, we're not actually going to do this, but let's say we want to survey the students of LSU about where to put a new parking lot, maybe where they would prefer it. So this is kind of a general, broad question, but the question we want to know is, which of the following options would give the most random selection? So we can't ask every single student who goes to LSU. We could try, but that may not be successful. So could we do the following? Survey students at the student union. Most students do attend the student union. For example, between 10 and noon on a Monday. Or survey those students who are in fraternities and sororities. Maybe we'd say a portion of those students. There's quite a lot. Okay. Or survey 500 students who attend classes on campus through email. So out of the three possibilities, if you want to think on it, you can pause it and then answer it. But out of these, if I want to know, if my population is an LSU student who attends classes on LSU's campus, then the best one would be C. If I only chose the students who are in fraternities or sororities, well, then that's going to, they would choose the one that would be closer to those houses. And that wouldn't really represent the entire LSU population. If I only surveyed students who come to the union, well, like I mentioned before, there's a lot of students who maybe don't even come to class on Mondays, or perhaps are in class from 10 to noon and they wouldn't go to the union. So those are not the best survey. This one's not great, but just for the sake of an example, that's the best one. All right, let's move on. So we can represent data in frequency distribution. We have a few ways to do this. So let's just take this set of data. This is 20 different numbers. These numbers represent the number of hours of sleep in a small Math 1029 class. They were surveyed. This is the number of hours they got the night before. All right. So yeah, there's 20 of them. You see some are decent, 8, 10, and then some are very low. Notice some of those repeat. So we're going to talk about that. So each entry, which I may call an entry, the book calls it a data item. So piece of data, data entry, data item, kind of all the same. And then in this case, some of those have multiple entries. So for example, 3, I'm going to circle it. 3 shows up twice. So we would call that data value. So I would say the value of 3, because that's my entry, is the number of times it shows up, which is 2. We're going to talk more about that in a bit, because we can take all of this data and make more concise representations. And that's what we are going to do next. So we can present the data in something called a frequency distribution table. We actually have 2 ways to do this. I'll show you both. The first one, we're going to take this data here. So in a minute, I'll show you that. But I'm going to make a frequency distribution table. And these have 2 columns. The left column is the individual data values in increasing order. So when I go to do it, my smallest number is 3. And then I got a 4. So I would list these all in increasing order. Okay, the right column is the frequency that it occurs. So that's what this is. The frequency of 3 is 2. That's how many times it shows up in this data set. All right. So let's see. I'm going to use the data. I might can fit it all right here. Yeah, we can see it. So my left column is what each of these numbers represent. Each of these numbers is the number of hours of sleep that a student slept. Okay. And then the number on the right, that's the number of students who had 3 hours of sleep, or the number of students who had 4 hours, which we'll write down. We might just call that frequency. So in the book, sometimes I see that they've done this. Usually they'll also, in parentheses, call it frequency. So let's just get to it. Here's our data set. There are 20 things, 20 entries. The smallest one is 3. And it occurs 2 times. Now, as I go through these, I think I'm going to highlight them so I know what I've included. Okay, so here's my 3. It occurred 2 times. Okay, let's move on. My next smallest, these are all integers, so my next smallest is 4. It occurs 1, 2, 3, 4, 5. Occurs 5 times. Again, I'm highlighting these so that I know that I've counted them. I know that there's a total of 20 items, 20 entries. So at the end, these numbers should add to 20 on the right side of the frequency. All right, moving on. 5. So 1, 2, 3. 6. Down. 1, 2. And then 7 would be next. There are 3. 1, 2, 3. And then 8. There are 1, 2, 3 of those. 1, 2, 3 of those. There are no 9s. So I could list the 9 if I wanted to. I don't need to. I think I'm going to put 9 just so I can put a 0, because where I might go with this. So I'll put a 0 there because there are no 9s. If you left it blank, that would be fine too. And there are 2 10s. Okay. So if I add these frequencies up, well, I better get 20. So let's look at that. I'm going to do that in my calculator. 2 plus 5 plus 3 plus 2 plus 3 plus 3 plus 2 is 20. Usually in the book, they'll show you the total. Okay, so that is a frequency distribution table. Frequency. They might just call it frequency distribution, but it is a table. All right. Now, that one was good because the numbers, the entries were just 3 to 10. But what if I had like test grades? Test grades would range, unfortunately, from 0 up to 100, or different. It could be different than that. But there would be a wide range. And, on my math lab, you would have things like 93.75. You might also have 93.4. So you'd have this wide range of entries, most likely none or very few that repeat. So if that's the case, then we might do something called a group frequency distribution, where we might lump some of these together. So I could have done 3, I wouldn't do it for this small of a group, but I could have done 3 to 5, 6 to 8, 9 to 11, you know, but it's a little better when we either have a lot of entries or there's not much repeats. Okay, so I found some data in the book. We're going to create a group frequency table with that data. I'll have to probably make certain to get all of this. But this data set represents the age at which each president was when they were inaugurated. So when they were sworn in, basically. All right. So George Washington was our first president, so he was 57, and so on, so on. This list, I should probably put it, this was as of 2017. Okay. So, what we're going to do is create a group frequency distribution table. Now, this is the nice thing. They actually tell us to use 41 to 45 for the first class. Okay. This is like each group. And then that's going to be the same class width each time. What I mean by class width here is going to be 45 minus 41. Well, I'm just going to show you in the table. Okay, so if you need to screenshot it or copy these down, you can. But as I go through my table, I will also show you these. So I think I'll do this and then I'll stop this video. It's probably going long. All right, so I've turned it sideways. I'm going to do something with this other space. All right, so they want us to do the class width. The first one is 41 through 45. Now, I went ahead and filled this out. This is going to be the age when they're inaugurated. And this will be the number of presidents. Okay, so the first class is 41 to 45. Okay, so 41 to 45 is 41, 42, 43, 44, 45. So it's 5 possible numbers. So I'm going to look at my table here, or my list of numbers. Anybody who was 41 to 45, I'm going to highlight and I'm going to tally this up. All right, there's a 49. There's a 47. There's a 43. Oh, there's a 42. That's it. So there are 2 presidents who were 41 to 45 years old when they were sworn in. All right. So the frequency is 2. All right. So 41 to 45 is the first class. Then we need 5 more. So we need 46, 47, 48, 49, and 50 is the next class. So it's nice and easy. It's every 5 basically. But if I were to just do 45 minus 41, well, that's 4, right? So that would be maybe a little confusing. Okay, so I'll go ahead and finish this. I'll have 41 to 45, 46 to 50, 51 to 55. These are nice because they're all on the 5s with the zeros. 61 through 65, 66 through 70, and I think that's as high as we're going to go. All right, so here we go. Here's this again. If you want to screenshot that or copy those down, you probably could just pause the video, do this yourself, make sure ours compare. But I'm going to go through it myself. All right, so 46 to 50. Here we go. So 46 to 50. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it took me a minute to find them all. All right, so there were 9 between those 2. Now 51 to 55. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I think is online. 9, 10, 11, 12, 13, 14, 15. Okay. I know I did those kind of quickly. That's the one that has the most, though. 56 to 60. 1, 2, 3, 4, 5, 6, 7, 8. Should be one more. 56 to 60. Let me count that again. 1, 2, 3, 4, 5, 6, 7, 8. I feel like I'm missing one entry. I'm going to come back to that. I'm going to probably pause the video in case I missed one thing. But go ahead and put 8 down for now because that's what I counted. Maybe I missed something. 61 to 65. 1, 2, 3, 4, 5, 6, 7. All right. As I counted this, I noticed I missed that 60. That was the one I missed earlier. Sorry about that. And then 66 to 70. We don't have much left. 1, 2, 3. So if you didn't quite do it that fast, you can pause the video. Make sure you end up with these numbers. You can use lines to separate these or not. Okay. This needs to total to 45 because we have 45 presidents up to this point. So let's double check that as you're copying those numbers. 2 plus 9 plus 15 plus 9 plus 7 plus 3. I'm going to move this out of the way. Let you copy that. I'm probably going to stop the video. Yeah, because now we're going to create pictures, create some graphs with this data. And when we put the data in this kind of visually pleasing way, it makes it easier to make the graphs we're going to discuss. So stop the video, pick up with